Can you see my Zoom controls? Can you see me admitting people?
No, please.
Okay, that's good. So my co-host is here today. Let's see. He has vanished. Where is he? Co-host, have you been given the access now? He knows himself.
Yes, I have.
Okay, so when anybody joins, you can admit them, and then just in case they unmute themselves, you can mute them for me.
Okay, sure.
All right. So let's start today's lesson. Another week has gone by, and we started this 2 weeks ago. Already, we are in our third session. We hope that today would also be a great session, and we can learn from the session today. Maybe before I go on, do we have any concerns from last week? Anything that we discussed that you didn't get, or any questions arising from last week's session? We could go ahead and ask now. I don't see any hand up, so I'll just move on. And just in case you have a question whilst we are having this session, you can raise up your hand and ask. So without much ado, let's get into it. You know me. And yeah, you guys know me already, so I don't think I have to present or tell you about myself again. You can connect with me on the URL or handle you see here. And I have some AWS certifications and some other certifications, yeah, basically. So let's start today. Today, our agenda is to look at the AWS global infrastructure. Then we'll look at what a VPC is and some of the resources in the VPC. Look at security when it comes to networking, or how you can use networking services to secure your workloads. Then we'll look at how we can connect VPCs. Then last but not the least, we'll look at DNS and content delivery. So let's get started. Global infrastructure. So in AWS, we hear what they call regions, availability zones, edge locations, and a lot more, right? So when we say AWS, it's actually made up of data centers in specific locations. So I think right now, how many regions are there? About 26 or so, right? So at 26 different locations, and there are some planned for this year and then the coming years, right? And they keep adding to that. So a region is basically a physical location. So it could be a city. A region could basically be a city, and you have a number of data centers in that city. So you say a cluster of data centers. Now, each region has what they call an availability zone. So an availability zone is a data center or a logical grouping of data centers. So that's like a collection of data centers. So an availability zone is either a single data center or a number of data centers that are grouped as one. So what will usually happen is that in a region, you have at least 3 availability zones. some regions have more than 3 availability zones, but you can't have less than 3 availability zones. So I mentioned earlier that there are AWS regions in several places, right? So there's EU West 2, that's London. There is EU West 1, which is Ireland. There's US East 1, that's North Virginia. US East 2 is Ohio. Then there's the US. There's even the Africa 1. Africa 1 is in Johannesburg or Cape Town, one of those. But there's a region in Africa as well. They have regions in Asia and other parts of Europe and all that. So they have regions all over the world. And typically, you would, when you are deploying your workloads to AWS, you choose a region that is closer to you. Because when it's closer to you, it's assumed, or it is likely that latency would be lower. So someone may ask, what is latency? It's just the time it takes to receive a response. So when you make a request, the time it takes to hear back. So if you are browsing and say it's slow, it means that your latencies are high because it's taking a longer time to get back or a response. But if it is fast, then it means that latencies are low. So just imagine when you are playing a game, right? Online game, maybe FIFA, and then you, on your control, a multiplayer game. So you dribble left, right. It has to respond quickly, right? Because you can't dribble at 10, 17, 15 seconds, and then it will reflect on the server at 10, 18, right? It will lag. So such applications require very low latencies. So when your latency is low, it means that your connection is faster. When it is high, it means that it is slower, or it takes a longer time to get a response. And the reason why your latency will be lower when you choose a region closer to you is because then the number of hops may reduce, right? Or the number of routers it takes a number of routers your requests or traffic traverse before it gets back to you is reduced, so it becomes quicker. That is not always the case, because routing is logical, and sometimes a physical location that's far away from you is actually closer to you than a location that's closer to you based on how the routing was done. So you choose a region for low latency. So maybe where your data center is, maybe your data center is in Accra. If you want to create a VPC or some workloads in AWS and you want to connect your on-prem data center to AWS, you need a region closer to you. So you either look at somewhere in Europe or maybe the Africa region, right? Or also another consideration is your end users, because they'll be using their applications or workloads. So you look at where most of your end users are, and then you deploy your workloads closer to them. Sometimes to regulation and compliance would insist that your data resides somewhere. It doesn't leave a country or maybe a continent. So maybe if you are in Europe and you can't process data outside Europe, then it means that the regions you use for your workloads or applications should be based in Europe, right? If you're in, let's say, South Africa, and then based on maybe the financial services regulation, you can't host your service in another country, then you are limited to the South Africa region, right? So you choose regions based on these factors I have given you. It's very important. Something you have to make note of. You don't just choose any region because it's there. Unless maybe you are just learning the cloud or playing around. Yes, but for a production workload, you have to consider all these. I've mentioned availability zones already, but let's take a deep dive. So like I mentioned earlier, an availability zone could be a data center or a collection of data centers. And most importantly to note, they have redundant power. That means multiple sources of power, so that when one fails, your service will not go down, right? So you have an alternate source of power, maybe 2 or 3, maybe a generator, and then maybe power from one power company, or maybe power from 2 different power companies, and a standby generator. And then you also have fiber connectivity. So how the availability zones are linked together. All the availability zones are connected to each other in a region. So you have multiple fiber connections to make sure that there's always connectivity between them. Now you use an availability zone to create highly available workloads, right? It would allow you to scale. Last week when we were looking at the auto scaling group, we realized we selected multiple availability zones or subnets. Even our load balancer, we had to select multiple availability zones so that when our workloads are created in the different availability zones and one of them goes down, you can still rely, or the availability zone itself is down. It happens a few times. Sometimes a particular availability zone may be down, and it would, if you have your workload there, you can't access it. So maybe it could be network related or even power related, or maybe a disaster, a natural disaster. You know? Yeah, so it's good to use multiple availability zones for your workloads. I mentioned that the availability zones are interconnected, and because it's a private network, the latencies are low, very, very low. And traffic between different availability zones in the same region are encrypted. So you don't have to worry about somebody snooping on your traffic. AWS makes sure that that encryption it's in there. Availability zones, we refer to them as AZs for short. So usually find them within 100 kilometers of each other. So in a region, like a city, like let's say London, you may have, maybe not all of us have been to London before, but you may have maybe the 3 availability zones spread across London, maybe between 50 to 100 kilometers of each other. Yeah, they are all not at the same place for the purposes of making sure that when one disaster occurs, or when a disaster occurs at one place, or something happens at one place, it doesn't necessarily affect the other ACs. So they are spread across, but they are interconnected with each other. Edge locations are AWS data centers. So these are, I mentioned availability zones are data centers, right? So these are not availability zones, but they are data centers. Sometimes, or mostly smaller than availability zones. You can't go and create your VPC, machine VPC, EC2 instances or maybe other AWS resources there. You can't do that in an edge location. What an edge location is used for is to reduce the latencies for some services or content. So maybe when you're hosting a website, and I believe we know what a CDN is. So that's a content delivery network. What that does is that it moves content closer to your end users. So maybe assuming you are hosting your application in US East 1, that's far away. It's a web application made up of HTML, JavaScript, and CSS, right? and your users are in Ghana, that's a far away place. So maybe their latencies may be higher. But when you use a CDN, what happens is that your content is cached closer to your end users. So when they try to access the content, they get it from a location closer to them than where your actual server is. So you realize that Google uses that a lot. Netflix also uses that a lot. So when you go to YouTube, sometimes you realize that your internet is slow, right? But when you go to YouTube, you're able to play the video smoothly. Like it plays as if your internet connection is okay. It's simply because somebody has watched the video closer to you and the video is cached closer to you. So they may not necessarily be going over the internet to get to that video. It's actually at a location closer to you. So I'm watching a cached version of the video. So the AWS uses edge locations for these things, for content delivery. One of the services that use edge locations the most is CloudFront. We'll look at it later. Lambda at the edge, we all know what Lambda is. This time around, you run Lambda code closer to you, so at an edge location. Maybe you can do that in response to certain CloudFront events. Route 53, we'll look at it later. There's an AWS service for DNS. It also uses edge locations to serve DNS queries so that DNS queries are quicker, right? You don't have to go to the region or availability zone somewhere which may be far away. WAF and Shield security services used to filter services. They can also operate at the edge level. So these are the only services that operate at edge locations. So we'll look at other AWS infrastructure, which may be similar to edge locations, but have different use cases. So edge locations are not used to run your workloads, but you use it to deliver content at low latencies to your end users. Local zones. So local zones are it's an infrastructure service from AWS, but this time around it's placed near to customers. You realize the similarity with edge locations, even though I've not dived deep into it. It is also placed closer to customers. The difference between this and an edge location is that a local zone is actually used to run workloads. So you can create your EC2 instances and RDS databases and all that in a local zone. So local zones, edge locations, there are lots of them. Think over 400 or so of them. They're all over the place. But local zones are few. It's a relatively new service. What it is that even though the AWS has regions, a lot of regions and availability zones, sometimes you have applications that you need to run closer to your end users. So like gaming, maybe virtual workstations like remote desktop and the likes, right? Or virtual reality and augmented reality. These services require high bandwidth and a low latency. And maybe a region may not offer, when you're running the services from a region, may not offer the latencies you are looking for. So edge local zones are an extension of a region, but they are placed closer to metropolitan areas. So you can actually run your workloads from a local zone instead of from the traditional region or AZ. It's an extension of a region though. Yeah. And local zones are few, and I think they can be found in a few, mostly US cities. Yeah, I'm sure in the future they will have a number of them around. So the difference between local zone and edge location is that even though they both are closer or are placed closer to end users, edge locations are used for content delivery, and local zones are used to run workloads, actual AWS workloads. Wavelength. Wavelength is also similar to or it's also placed closer to customers for the purpose of low latency and high bandwidth, right? The difference or the catch for wavelength is that wavelength is purposely for 5G applications. So if you are into the network space, you realize 5G is what is going to answer all our problems, right? It's mostly, or Internet of Things would benefit from it. So our cars and our traffic lights and all that would use 5G networks to connect to maybe an application, and then based on that function properly, right? When you have such applications supporting 5G services, you don't want, you have to offer low latencies, right? Or you can't go over the internet to an AWS region to get that information, or to get to your application. That may defeat the whole purpose of Internet of Things or supporting real-time applications, right? So wavelength, AWS partners with telecom service providers or SPs, yeah. They partner with telcos or SPs, and then they place their infrastructure in their network. So this makes the AWS infrastructure will now be in the network of the telco. And when you have a 5G application, the telco can run 5G application, maybe an application that for self-driving cars or for some IoT service and all that, right? We run it in their network. So this makes the application closer to the end users, right? So you typically need what they call a carrier gateway to connect the telco network to the internet or to AWS. And then with wavelength, you can run your traditional AWS services. So wavelength is similar to local zone. The only difference here is that wavelength is run in a 5G network, and local zone is a general purpose edge service for running AWS workloads. Outpost, one of my favorite AWS services. So now we've spoken about regions, we've spoken about local zones, we've spoken about wavelength. There are times where you want to run an AWS service, or you want to leverage an AWS service, right? But now in your data center, Outpost makes this possible. So you run AWS in your own data center or office or your house. If you are rich, you can buy one and then put it to your house and run RDS or ECS anywhere on it, right? Yeah. So Outpost is available as a server or as a full rack. You can order maybe a 1U. Use how you count server. So it's just a server space. So a typical rack would, a full rack would usually have 42 U's. So you can buy a full rack, or you can buy multiple racks, or you can buy a 1U Outpost server or a 2U server, and run your EC2 or RDS or any AWS service you wish to run on it. So usually, I mentioned earlier that for compliance purposes, right, you may not be able to run your workload in a certain region, or you have to run it locally. So you can use Outpost to achieve that. Actually, you can order. Why will you want to order service from AWS to run your workloads? Because of some of the heavy lifting that has been done for you. So when you have an Outpost, you can apply your IAM rules. You can use CloudWatch, alerting and logging and all those things. So you use your traditional AWS services locally. Yeah, you can use it to process your data locally. Maybe you want to do a migration, but it is dependent on some applications you have running locally. So when you use Outposts, you can get your service, some services running in AWS, and then connect them to the dependencies you have locally. So you may not even need to connect your on-prem data center and the cloud, because now you have the cloud in your on-prem. So that's what Outpost is used for. And you can run your most AWS services on it, like EC2, AWS, and the likes. So we've spoken about global infrastructure. I thought I should add this slide, which has the numbers. So you have 26 regions. About 8 of them have been announced. So as time goes on, they keep adding to it. So maybe by next year, we'll have like 30 regions. There are 84 availability zones. 17 local zones, 28 wavelength zones. Then AWS has 2 times more regions than any other cloud provider. And they currently serve about 245 countries. There are 108 direct connect locations, and then 410 plus points of presence. So you see, point of presence is either an edge location or an edge regional edge cache. So you see the number of points of presence here. That's a lot. All right, so that's the AWS global infrastructure. That serves as an introduction to our session today. I'll pause here. Do you have any questions? If we don't, I will just move on. The late comers, they can't ask a question. If you're late, you can't ask a question. All right. Looks like there's no question. So we move. VPC resources. So one of the things when you start here, when you start using AWS is VPC. VPC means virtual private cloud. So let's look at what it is. I've mentioned your on-premise data center, right? And and before we started, we had a small session before we started where we're talking about CIDRs, private IPs, and how you subnet them and all that. So usually when you have a data center on-prem, or even an office and you have a network, you'd have some IP range you use in that network, and that IP range is usually private. Until you go and buy an internet service and route your private network to the internet, you would not be able to access the internet, and nobody outside that network will be able to access anything in the network. So that's when you have a LAN, it's only systems or machines on the LAN that can communicate with each other. Unless maybe you go and buy internet service and do some routing, or you go and buy a wide area network or create a wide area network with another office somewhere. And then now you can connect with the other office also. So that's what the VPC is. It's basically your data center in the cloud. It is private, it is secure, it is isolated. So you create a VPC, you can't connect outside that VPC. So you provide a connection that allows that, whether internet or to another VPC or to on-prem. However, there are ways to connect your VPC to other VPCs or your on-prem data center or to the internet or to any other remote network you wish. But when you create a VPC in itself, it has no connection, right? And the pre-reading material I gave you, or prerequisites for today, was what we call CIDRs and all that in there. Good. So when you create a VPC, you need to specify a CIDR. CIDR means the full The full meaning of CIDR is classless inter-domain routing. Yes, I think that's the full meaning. And it's basically an IP address block. So when you create a VPC, you need to specify an IP address block. And then from that, you can create multiple subnets. So subnets is the sub block of the main block you give. So maybe you give a block that can support about 60,000 IPs. Now you can break it down to support, for each block to support maybe 2,000 IPs. We'll look at why you do that. So VPCs use gateways and endpoints to route traffic, right? So I mentioned earlier that when you create a VPC, you can't communicate outside it. So you provide other connections that will allow you to do that. So gateways and endpoints are what will allow you to do this. We'll look at that shortly. And then let me mention here that a VPC has what you call an implicit router. So a router routes or what forwards traffic, right? That's what a router does. So an implicit router means that the router is not there, or it is create a router, but it is there by default. Like it works like a router. You not create any router, but there's a router there. So we'll say it's an implicit router. What does it do? By default, or when you create a VPC, every IP in the CIDR block can communicate with every IP in the subnet, in that CIDR. So whether you break it down into 5 subnets or 10 subnets, all the subnets can communicate with each other. You can actually create subnets for different availability zones, and they'll still be able to communicate with each other. With that being said, a VPC is created in a region. So it means that when you create a VPC, you have, you can use the VPC, or the VPC extends to all the regions, all the availability zones in the region. You can create subnets. We look at what subnets are. You can create subnets for every availability zone. You can create multiple subnets. And every instance in a VPC can communicate with every instance in the VPC. Maybe I should add a caveat now that I've started saying you can communicate with each other. You remember our friends who were called security groups? They'll come in the picture again. So maybe I shouldn't be so confident that every IP in the subnet can communicate with every IP. Okay. So subnets are, I mentioned already, are a range of IP addresses, and you typically launch your EC2 and RDS instances, or even network interfaces into subnets, right? And you can allow subnets to connect to the internet or to your on-prem location, that's your data center, or to other VPCs. And route tables help you do that. So a subnet can really reside in an availability zone. So a subnet is tied to an availability zone. So when you launch instances into different availability zones in the same region, what you're doing is that you are protecting your workloads from failure if one of the ASICs should fail. So last week, we created a load balancer with an auto-scaling group with 2 instances, which were in different availability zones. We didn't look at that really, but they were actually in 2 different availability zones. So what that meant is that if one of the availability zones fail and our instance in that availability zone becomes unhealthy, then our load balancer would now route traffic to only one instance in the other availability zone. Yeah, so our auto-scaling group would realize that our instance is failing a health check and then place it. So that brings us to route tables. A route table is not unique to AWS, but I think AWS has some special other things they add to route tables, right? So if you have a background in networking or you know some networking, you know that route tables basically contain rules on how to route traffic. And so in AWS, the route table contains a destination and then a target. A destination is the destination of your traffic. So if, let's say, I type YouTube into my PC right now, my destination for the destination of that traffic will be youtube.com. It will actually be an IP for YouTube, not necessarily the domain name youtube.com, right? And then the target is where that traffic should be routed to. So your targets will know what to do with the traffic most of the time, right? So, or yes, it should know what to do with the traffic. So an example would be that if you want your VPC to access the internet, you're going to create a destination of 0.0.0.0/0. 0.0.0.0/0 is used to represent all traffic. All traffic. So you are saying that any traffic that we have not explicitly defined a route for should go to that target, which will be your internet gateway. We'll look at that later. So that's destination and target. Destination is the destination of your traffic. Target is which device or gateway or routing the equipment that traffic should be forwarded to. Your main route table. So when you create a VPC, it comes with a main route table. You can create other route tables also, and that is called a custom route table. Now you have to associate when you create a route table, you have to associate a subnet with it, or an internet gateway, or a virtual private gateway, right? So that's route table association. You have to associate subnets or other gateways with it for the route table to apply. So you mentioned earlier that I said every instance or every resource in a VPC can communicate with any other resource in the VPC. So it's a local route that allows that. The local route comes with every route table, and all it says is that all traffic from the VPC is local, meaning that the implicit router in the VPC should take care of it. It's internal to itself, so it knows where to find it. So that can be found on the every route table. Then propagation. I've mentioned that we have route tables where you make entries on where routes should go, right? Propagation, it's a bit different. Now, when you create, let's say, a VPN, you may not know all the routes. So the VPN gateway can propagate those routes. By propagating, it means that it will dynamically add those routes to the route table. So that's propagation. That's like a dynamically adding routes to your route table. It's 10:50. Let me see. I think I have. Okay, so let's do the default and non-default VPC. Then we'll share VPCs. Then we can take a break. And then we'll come back. Today maybe we'll do only one demo, but that one demo is like a mega demo too. All right. So default and non-default VPC. When you enable a region in your AWS account, by default, AWS creates what you call a default VPC. A default VPC has certain characteristics, right? So it will come with subnets, which are called default subnets in each availability zone in the VPC. It also comes with an internet gateway. We'll look at an internet gateway, but what an internet gateway does basically is to give your VPC access to internet. It comes with a route table, and that route table sends all traffic to the internet gateway, basically saying that all instances or any basically saying that your resources or workloads can have access to the internet. Okay. Then the default VPC also comes with the DNS setting that gives EC2 instances, public IPs, and then DNS names. You can create your own VPC. And when you create your own VPC, it's not a default VPC. So that would mean that all these things I have mentioned, you have to add them if you want, if you need their functionalities, right? When you can create a subnet in a default VPC, but a subnet you create is a non-default subnet. And of course, when you create a non-default VPC, all the subnets you create will be non-default subnets. So that's default and non-default VPC. So if you want to, a default VPC is ready to use. But sometimes you realize that because of the workloads that you're running or security and all that, you don't need a default VPC, and then you want to create your own VPC and customize it per your requirements. So that's when you create your own VPC. So when you create an instance and you don't specify a VPC, what AWS would do is use a default VPC. So realize that in our demos so far, we've not created a VPC, which means that we're using a default VPC. Okay. You can also share VPCs, right? Why would you want to share VPCs? To simplify this, realize all the things I've mentioned here with internet gateway, route tables, and all that. That's just a tip of the iceberg. It goes way beyond that. Sometimes it becomes complex to manage these things, a lot of them, right? So maybe you have use AWS organization. We're supposed to look at organizations in the first session, but we couldn't. Organization basically is a collection of AWS accounts. So a company or an organization, not an AWS organization, but organization in the sense of a company or an institution can have several AWS accounts. You can use AWS organization to bring them together and centrally manage them and even have a consolidated bill. So they will add all your bills together and present you with one bill, right? But most importantly, organizations help you control access. If you remember from our first session, we spoke about session control policies. So you use SCPs, that is the service control policies, SCPs, to control the level of access each account has, right? So back to VPC sharing. If you use organizations, you can use that. I think there's a feature called RAM, Resource Access Manager or something. Sometimes these acronyms get confusing, right? Yes, but I use that to share your VPC. So other accounts can launch resources into that VPC or subnets you decide to share with them. And they can delete resources they create. Yeah, they create, but not those of others. Yeah, you still, the person who is sharing the VPC still has full rights to the VPC and can decide what to do with it. But the others can now create resources from it. Create resources into it, sorry. Yeah, so I mentioned earlier, it reduces the number of VPCs you need to create. So sometimes organizations have what they call central services, right? Or managed services. So it's a service that different parts of the organization uses. So when you have such services, you can use VPC sharing to host such workloads, right? Yeah, so you can launch EC2 RDS, Redshift, even Lambda functions, right? Into shared VPCs. So I think we can take a break. It's 10:55. We'll come back at 11:05, and then we'll look at the security aspect of networking. And then from there, I think we'll go ahead and do a demo, should we? Yes, we'll go ahead and do a demo and then come and continue. Or we'll even move on to the next session, then after we'll do the demo. So let's take a break. We'll be back at 11:05. Welcome back. If you have any question, you can ask. So should we get ready to come back? All right. Yes, we can come back. Any questions so far? Today, myself, I feel like I am running. Is the tempo okay, or I should slow down a bit? Okay. Yeah, Daniel, you can go ahead and ask a question.
Okay. Good morning, everyone. Good morning, Emmanuel. So I joined a bit late, but I would like to ask on the VPC, the creation of the VPC. What I do realize is that when you try to create one on your own, it by default you don't have connectivity in the VPC. How do you first try to ensure there's connectivity in the VPC for a VPC created on your own?
Okay.
It's something I've had a problem with in the past.
Yeah. So, hey, instead of going left, you are going right. Interesting. Okay, good. So on this slide, right, we spoke about default and non-default VPCs. Default VPCs come with a VPC, or default VPC comes automatically with regions that you've enabled. So when you create an account, you can enable regions, right? Some regions are automatically enabled for you. So all those will come with a default VPC. And that default VPC has subnets in every availability zone. There's an internet gateway, there's a route table that sends traffic to the internet gateway and all that. So that one has connectivity to the internet. The DNS settings are such that your EC2 instances would be given a public IP and then also a DNS hostname, right? However, when you create your own VPC, like you said, you don't have all this. You have to create all this yourself. And the good thing is that in our demo, we are going to create a VPC on our own and then get all the connectivity in there. So I believe we can answer your question fully in the demo. Is that okay?
Sure. Thank you.
All right. Any other questions? And that we move. So where did we get to? Security. I can go on, right? It looks like we finally settled on the membership of the Bootcamp. I think now we are settling on the 20 number. That's okay. Okay. So let's go. Then our friends, security groups, that's the first one. So we use security groups to control traffic to an instance. So you create some rules in there. The rule would basically have the protocol and then the source, right? The protocol and the source. I think these are the two main, there's the port protocol and source, right? And when you create, that rule will determine what kind of traffic is allowed to enter an instance. The catch with the VPC is that you have to attach it to the instance before it applies to it. So I mentioned already that a security group contains rules, and the rules are what you use to allow traffic. The interesting thing about security groups is that it only has allow rules. there are no deny rules. So when we're looking at IAM, we spoke about implicit deny and explicit deny, right? So there's no explicit deny here, right? It's just an implicit deny, which means that if you are not allowed, or if there's no match for the traffic that is coming in from that specific source, then by default, you are denied because there's no rule to allow you. One other concept we have to note is that they are stateful. When you say something is stateful, all it means is that it remembers. Yeah, that's, I think, the simplest explanation we can give to a web where stateful. What do we mean by remembers? It means that when you create an inbound security group or an inbound rule, sorry, that's traffic entering your instance. When you create such a rule, by default, the outbound for that same rule would work. So you don't have to define a separate outbound rule for a certain inbound traffic. Is that clear? So for instance, if I say an instance should allow port 80 from anywhere, right? It means that by default, my instance can also can connect to port 80 on any IP. Do we get this concept? It's very important. This is a very important. So you don't have to define, when you create an inbound, you don't have to define an outbound for that same, no. The inbound will take care of the outbound automatically. So we say it's stateful, because it remembers that you said the one direction is allowed, so automatically the other one too would be allowed. Let me also mention that when you create a VPC, it comes with a security group. That security group is called a default security group or a VPC security group. The rule it contains is that all traffic is allowed for any instance with that security group. That's the inbound rule. The outbound rule is all traffic allowed. So it means that when a traffic is coming from, so this is used when you create a resource and you don't attach a security group with it. They would attach the VPC security group. So it means that any other instance with the VPC security group can access your instance. If you don't understand, ask questions, so I'll explain. These are very basic concepts you would need for the networking parts of the exam. Okay. Now, another feature that works like security group is a network access control list. Ernestina, yes, you can go ahead and ask your question.
Okay, so I wanted to find out if there are instances where it will be appropriate for you to not set a security group, so you just go with the VPC's security group.
Okay. So the VPC security group is allowing inbound traffic for any instance with the VPC security group. So if you have a scenario where somebody outside the VPC needs to access the instance in question, then that will not work, because that person that person will not have the VPC security group attached. But if it's an application that only needs connections from other instances in the VPC, and those instances have the VPC security group, then that is okay. Is it clear?
Yeah, that's clear. Thank you.
So network access control list. Ali, go ahead. I like that you're asking questions, because this is very confusing.
Yeah, hello. Yeah, where we have VCPE peering, can one instance also have access to another instance in a different VPC?
Okay, so when you do VPC peering, it means that you have to set your your security groups, right, to allow the VPC peering to work. So security groups are attached to instances. So if your instance does not have any rule that allows traffic from the other VPC, then it won't work. So you have to set your security groups right. Yeah, Daniel.
Hey. Hello.
Yeah, go ahead, Daniel.
Okay, so I just wanted to ask, in line with what my colleague just asked concerning VPC peering, does it mean it's when you're setting the security group, does it mean you need to be in the same you have to have the same route table? I don't know how to put it, but
okay. So let's pray we have some time. We can do a demo on VPC peering and then see all the nitty-gritties and some of the challenges you encounter, right? But let's understand it this way. So on a high level, right, do I have a note on VPC peering coming? First of all, Emmanuel. Okay. So let's see VPC peering. Okay. So there's a VPC peering demo. Okay, fine. Maybe let's wait and do the demo, okay? That's if we get there. If we don't get there, then I would explain what it is. So let's hold it. There's no other question. All right. So we can move on quickly. So network access control list. They have, yeah, Daniel, go ahead.
okay.
About network access control list. Yeah. Go ahead, Daniel.
Okay. Okay, so I just wanted to ask, if it's okay, I know security is an issue and you need to put them into practice well, but is it okay to just establish obviously your VPC and also have your knuckles in place without implementing security groups? Would that be okay, or is not proper?
You see, at the end of the day, you need to understand what knuckles are doing and then what security groups are doing. They are doing almost the same thing, but at different levels. So maybe let me explain knuckles, then I'll come back to your question. So knuckles, unlike security groups, have allow and deny traffic. The difference is that knuckles operate at the subnet level. So I mentioned that you attach security groups to instances, but you attach knuckles to what? Subnets. Instances can be found in subnets. So it means that the work the knuckle is doing can be done at the subnet level, okay? However, you may have a subnet that would contain different kinds of instances, right? So the same knuckle may not work. So for instance, if you have a subnet that contains a web server listening on port 80, and then you have another instance in that same subnet. This time it's not hosting a web server, but it's running some batch process for you. So some data processing, and you may need to connect via SSH, right? To connect to that instance. Now your web server, you do not necessarily need to connect via SSH to it because you can have logs from it pushed to an external login service like CloudWatch or even maybe Elasticsearch or something else, right? So you need to allow SSH for your EC2 processing some data, and then you need to allow for 80 for your web server. if you create a NACO, you have to do this at the subnet level. You do not need SSH or port 22 at the instance level for the web server. So if you create a NACO for this, then you are over allowing access to your web server. We spoke about principle of least privilege in week 1 when we're looking at security. And principle of least privilege says that give access, only the required access or permissions to an application or a user, right? So you have to apply that principle everywhere. You only give what is needed. So you can use NACOs to control traffic at the subnet level. But this time around, if that same traffic is allowed for everybody, or you want to deny for everybody in the subnet, then you do that. If you want to do specific allow or specific access, then you use the security group. Now the question is, assuming that my web server, let's say was 80, right? And then my instance running some batch process, right? Which I need SSH port 22. In this scenario, what I'll actually do is I have to allow both port 80 and 22 at the subnet level or the NACO level. I have to allow both. However, at the instance level, I have to allow port 22. Sorry, port 80 for the web server. I have to allow port 80 in the security group for the web server. And then for the batch process EC2, I have to allow port 22. What this will mean is that at the subnet level, we'll accept traffic for both ports, but when you get to each instance, the security group would allow for a specific port. Is that understood? Or I should take that again? Come again.
It's well understood.
It's not understood.
It's well understood.
It's well understood. Good, because if I allow only, let's say, port 22 at the subnet level, that means that port 80 traffic cannot even get to the instance in the first place for a security group to say I'm allowing or not. So we have to look at that. By default, every VPC will come with a default NACO. The default NACO allows everything, inbound and outbound. If your VPC supports IPv6, there'll also be a default a rule for that as well. The NACO, every NACO has, so NACOs usually have a number and then your rule. So that you'll have a number, the rule will basically be the type, whether it's inbound or outbound, the protocol, the port, source, destination, and what have you, right? And then the decision whether to allow or deny, right? But there's a number which is asterisk, and that's like a default. That's a default deny for every traffic. So if if you are familiar with access control lists, I think that's where they got the NACOs from. You number your rules, and that's the same thing you do for a NACO. The last rule is a catch-all, which is a deny. So if none of the rules above were evaluated, then the last one, which is the asterisk, applies. So for instance, we can have a NACO with a rule number 10, which allows port 80, a rule number 20, which allows port 22, right? And then the asterisk, which is a deny, meaning that when I come with a 443, which is HTTPS traffic, the NACO would deny me. And once you see a deny, the evaluation stops, right? Once you see a deny, evaluation stops for that particular traffic. That's for a NACO. So each subnet in the VPC is associated with the NACO. I mentioned that when you create a VPC, it comes with the NACO, which allows everything. Good. So if you create a subnet and you don't associate it with the NACO, then a default NACO is used, and a default NACO allows everything. And that's how come so far we have been looking at only security groups, because the default NACO is allowing everything. If we had a NACO in place that was preventing some traffic, like we would still not be able to access our instances. So that's with NACOs. This is a table comparing security groups to NACOs. Security groups operate at an instance level. NACOs operate at a subnet level. That's the key difference. Security groups have only allow rules. NACOs have both allow and deny. Security groups are stateful. NACOs are states. So I mentioned that stateful means you remember. And what that means is that you can define only an inbound and then the outbound will work. Stateless means that you have to define both inbound and outbound for a particular traffic to work. For a security group, you need to attach it to an instance before it applies to the instance. NACOs apply to the instance if it is in the subnet the NACO is associated with. And then for security groups, you can attach multiple security groups to an instance. So for security groups, evaluate all the rules in the various security groups attached to that instance and then make a decision. If there's a match, then it means that you're allowed. For NACOs, it's evaluated in order. I mentioned the numbers. The numbers signify priority. So the lower numbers will have priority over the higher numbers. And so the rules are evaluated in order. When they find a match, then you are allowed. So those are the differences. VPC flow logs. So what VPC flow logs basically does is that it allows you to capture traffic entering or leaving network interfaces in your VPC. So a network interface, when you create an EC2 instance, it has a network interface. When you create an ECS task, it has a network interface. The network interface is basically a virtual interface that acts as like a NIC. Your computers have a network interface card, right? And that's what a network interface is in AWS. It's just a virtual NIC which does all the networking stuff. So it's assigned an IP and all that. So it captures that kind of information. So what this means is that it can capture traffic entering or leaving your instances, because your instances have a NIC. Flow logs can be created for the entire VPC or subnets or specific network interface. So I can decide to create a flow log for maybe my NAT gateway, maybe, yes. Or a specific subnet or the entire VPC. When you're creating a flow log, you can decide to only capture the allowed connections, right? Or the rejected connections, or both. You can publish the flow logs to either CloudWatch logs or S3. Mind you, when we're treating IAM, we said that every service needs access or permissions before it can use another service. So in this case, you need to give the flow logs permissions to be able to publish to CloudWatch logs or S3. Okay. So why flow logs? You use flow logs to diagnose the traffic entering or leaving your VPC, right? When you diagnose it, it will let you know whether your permissions are restrictive or they are overly permissive. So restrictive means that there are certain kind of traffic you should be allowing, but it's not allowing. And then overly permissive means that you are allowing traffic that you shouldn't allow. So for instance, the web server we mentioned earlier, they need SSH for remote connection, but maybe we give it SSH. So when we see that, like, why do we even need SSH on this server? We don't need to connect to it. We already have the application running. We have logs, it's observable and all that. So we don't even need to log in directly to see what is in there. So when you use flow logs, you will see all this information. And then now you decide to maybe go and update your security groups and then the knuckles. Traffic mirroring. So traffic mirroring, quite similar to flow logs, but then this time around, you are copying the traffic entering or metadata of the traffic entering or leaving your network interface to a third-party appliance, right? So when you hear an appliance in AWS, so an appliance is a software version of maybe some physical hardware. So maybe a firewall or an intrusion detection and prevention system, something like that. Those are appliances. And what they are in AWS are basically AMIs. So it's a software you can go and buy from the marketplace and then install on your instance, and then it will provide that functionality for you. So yes, it will allow you to copy the traffic from your networking interface to an appliance. Why will you do this? Maybe you want to inspect the traffic entering your network interfaces. You want to troubleshoot something. Some connections are not working, or some traffic are not going or being routed as they should. So you could use that to troubleshoot. Or you want to monitor threats. Maybe some bad actor somewhere is trying to access your services. So you can use traffic mirroring to copy the traffic to an appliance that can look at the traffic and then tell you what is happening. Okay, so what's the time? 11:32. Daniel, go ahead.
I just wanted to ask, do we have an alternative for the appliances?
The appliances are at the marketplace, so there are a lot of them from different vendors.
Okay.
From different vendors, so you can choose what you want. And these are the popular ISVs, you know. So you could have an appliance from Palo Alto Networks. Have you heard of them before?
Yes, please.
Yes, they are a security network security company. Yeah. You could have from even those what they call them, consultancies like Accenture and Deloitte and those people. So people who sell software on AWS will typically go and put their software in the marketplace as an AMI, and then you can buy them. Basically. So 11:33, let's go to the next session, and I think we'll do the demo as we'll go for a break. Let's move on to the next session. We'll go for a break, then we'll take the demo in the last section of today's session. Yes. Is that okay? So let's look at how we can connect our VPCs, because we need some of these concepts will be used in the demo. So let's look at them first, and then we can come and do the demo. So internet gateway, if you want, think of it this way: if you want your instances or resources in the VPC to access the internet, they need an internet gateway. When we look at subnets, I didn't mention one key thing, right? A subnet could be private or public. What that means is that a private subnet means that the subnet doesn't have access to internet. And a public subnet means that the subnet can have access to the internet. So you use an internet gateway to provide internet access in your VPC. And It's horizontally scaled, meaning that if there are lots of traffic, internet traffic from your VPC, then they will add additional resources to the internet gateway too, or additional internet gateways or gateway components, let me put it that way, to handle that traffic. It's highly available. Yeah, so I mentioned that it allows instances in your public subnets to connect to the internet. The catch here is that when you use an internet gateway, it means that your instances can also be connected from the internet. Why is that important? When it comes to internet or networking, basically, there's a concept called NAT, which means Olivia. Did she raise her hand? Hi, Olivia, did you raise your hand? If not, I'll continue. If yes, you can unmute and ask a question. Okay, no response, so it means that she didn't raise her hand. Let's go on. Yes, so NAT is network address translation. And remember when we started, I mentioned that in your LAN, you have private IP addresses and you can't connect externally to go and buy internet or maybe a WAN or something, right? Yes, it's the same in a VPC. Your instances would have private IP addresses. If you need to access internet, you need a public IP. So a NAT is basically saying that this private IP is mapped to this public IP because you need the public IP to go to access the internet. So if you have a public IP, we have an instance, a web server, it has a private IP. If it wants to download our application from the internet, it needs a public IP. The internet gateway would perform that function of mapping the public IP to the private IP. Mind, when we're creating the instance, we said that it should be given a public IP, right? But that public IP is not actually, the instance doesn't actually know that public IP. It only knows the private IP. So when it initiates an internet connection with the private IP, the public IP will say, okay, you are this instance, this is your public IP. Let me go and fetch whatever you are looking for you and bring it back. When somebody outside your VPC wants to access the instance, so maybe when we are doing an SSH, you realize that when we are doing SSH into our instance, we're using public IPs, right? So when that happens, and then we get to the internet gateway says, okay, this IP, oh, I know this IP, right? This public IP, I know the private IP that's behind or it's linked to. Let me route the traffic to that private IP, which is your instance. So internet gateway does NAT. It actually also does what they call, it's okay, let me not confuse you. Yeah, so an elastic IP. So we are talking a lot of abstract things, right? Elastic IP is a public IP. However, you realize that when you stop your instances, right, they would get a new public IP. So an elastic IP is an IP you can have in your VPC and you can allocate to any instance in the VPC. Of course, one instance at a time. But what this means is that if that instance should fail, or should you restart the instance, stop and start the instance, and you can still assign that same elastic IP to it. So it's a public IP, it doesn't change. You can assign it to one instance at a time. When your instance fails and you create a new instance for that same application, you can now reallocate the elastic IP to the new instance. So it makes sure that you have you have a public IP, a static public IP all the time you can reference. You can use this in your DNS records, irrespective of the actual instance it's mapped to. You don't have to change the DNS record when your instance changes. Let me give you, maybe it sounds abstract. Let me give you a situation where you need an elastic IP. So let's say you have an on-prem data center, right? And you have an application or a service that you need to whitelist an external IP to use the application, right? We know about wireless, allowing certain IPs. Good. I mentioned earlier that instances can fail, and when they fail or you restart them, they get new public IPs. So it means that every time, if you have an instance in AWS that accesses your on-prem service, which is whitelisted, or even another service in AWS, which is whitelisted, or another service with a SaaS provider or a third-party service provider, right, which is whitelisted. It means that every time your IP changes, you need to go back to the service provider or to your on-prem service team to change the whitelist. You can use an elastic IP and then whitelist the elastic IP. And then every time you make sure the elastic IP is attached to the instance you want to link or to access the service that requires whitelisting. Yeah. So it allows you to max the failure of maybe an instance. Yeah. That's what an elastic IP is. So we've been talking about IP version 4 mostly until now. And Internet Gateway works for IP version 6 also. But then in IP version 6, all IPs are public IPs or accessible over the internet. Right? So sometimes you may have workloads using IP version 6 and you don't want them to be accessed from the internet. So use an egress-only internet gateway. Egress means outgoing. It means that only when you're accessing the internet, then that internet gateway is used. This is specifically for IP version 6 related instances. So it will allow outbound internet access, but not inbound. You don't want people to access your IP version 6 instances from the internet, but you want them to be able to access the internet, maybe download some software or update the instance and all that, right? So, yeah. What happens after creating an egress-only internet gateway? You have to update the route table, and then your destination. The destination you see the ::/0 is the IP version 6 equivalent of the 0.0.0.0/0, which signifies all IP version 4 IPs. This also signifies all IP version 6 IPs. So your target is your Ethernet, egress-only internet gateway, and then your destination is all the IP version 6 IPs. Of course, you can associate the subnets you want with the route table. So NAT gateway, maybe we should have looked at NAT gateway before the egress only. NAT gateway actually works or performs the same function as the egress only internet gateway. However, this is only for IP version 4. And it's called a NAT gateway because it performs NAT related activities. The difference between a NAT gateway and an internet gateway is that NAT gateway would allow your private subnets or instances in your private subnets to access the internet, but they can't be accessed from the internet. So it means that if I have an instance in a private subnet, right, I can't use the public, or I can't SSH to it from the internet. or I can't use the public IP to reach that instance. It will even not have a public IP. The NAT gateway will have a public IP, which is actually an elastic IP. We looked at elastic IP just a few minutes ago. So when the instances in the private subnets want to access the internet, when they get to a NAT gateway, the NAT gateway will use its IP. So it means that whichever resource we're trying to access on the internet, they know the source to be the NAT gateway and not the instance in the private subnet. So with that, they'll go and get the request, come back, or response, come back. The NAT gateway says that, oh, okay, you're the one that I requested this for on your behalf. So take your response. Yeah, so it performs NAT and then actually PAT. PAT is port address translation. So port address translation is like network address translation, but this time on ports. So it's basically you use PAT so that you can use one public IP address for multiple private IP address. So maybe request for IP address 10.0.0.3 will go on maybe port 40,000, and then for .4 will go on port 40,001, like that. So that's how you can use one public IP to serve so many private IPs. Yeah. And then instead of using a NAT gateway, now you can actually go and use a NAT appliance, right? You can go and buy or go and download or use a community AMI that performs NAT and use that on an instance. So you run that NAT software on an instance, and then you route all your traffic from the private instances or private subnets to the NAT instance. To do that, you need to do a few things like disable the source and destination. EC2 has a feature called source and destination check, which would basically check if the traffic originating from the instance has a source IP of that instance. Yes, so that's the default. However, when you're using a NAT instance, this will not help, or this will prevent it from working, because the source is actually your other private instance which wants access to the internet. However, your NAT instance will see its source as the IP of the NAT instance. So you have to disable that so that it will not drop the packet. And then that would move the traffic. So your route tables, you can actually define a network interface as the target. So that's where you would use the network interface of the NAT instance as your target to route your internet traffic. But how do you want to do this when AWS is already giving you a NAT gateway? So yeah, that's just by the way. You have to know that you can use a NAT instance for private subnets or a NAT gateway. NAT gateway is from AWS. NAT instance is either from you or from a third-party provider or from the community on the marketplace. Private link. We are looking at different ways to connect your VPC with us, right? So private link, you realize services like IAM, S3, Lambda, and all that, they are accessible over the internet. However, private link allows you to connect instances from your VPC or instances in your VPC to use those services without going over the internet. So it uses Amazon's private network, right? It's private global network. So you don't go over the internet. This is for security purposes, right? So you could actually have private subnets that do not have internet access, but then they can use private link to access all the other AWS services that are exposed publicly. VPC endpoints, we would see VPC endpoints in our demo. So they use private link to allow you to access AWS services. You could use private link to also share your own services, right? So maybe you have some software as a service you can use, and then it's hosted in your VPC. You can use what they call endpoint service to share those services. It's how other people share their or deploy software as a service in AWS when they have it's in a VPC. So other people can connect privately to your services, your VPC, using endpoint services without going over the internet. And all this is powered by private link. Joey, I see your hand is raised. You can go ahead and ask a question.
Good morning.
Good morning, Joey.
Please, a question. You did mention that private link uses VPC endpoints to access other services.
No, VPC endpoints use private link, or is based on the private link technology to access other AWS services without going over the internet.
So does it mean this is a more or less like a principle, a laid down principle or rule that applies to all services?
No.
Okay.
So traditionally or typically, you access S3 over the internet. That's how come when you go to, when we open our console, you can open IAM because we are using internet, right? You can open IAM and then create a policy and a rule and all that. You can go to S3, create a bucket, drop a file from your computer into that. All that's accessible over the internet. We mentioned earlier that VPC is isolated, it is private. It does not send traffic over the internet until you attach an internet gateway to it. So if you have a VPC and there's no internet gateway, it means that you can't access other AWS services because there's no internet gateway. Now, if you have service, even if you attach an internet gateway, only your public subnets would be able to access other AWS services. What happens to your private subnets? The way to allow those private subnets to use other AWS services would be through a private link, or let's say the VPC endpoints. What happens here is that VPC endpoints would give you access to the same AWS services without going over the internet. So it would use Amazon's private link. Remember that every network is private before, and then it has an internet site, or it's exposed to the internet. So your private VPC or your VPCs can communicate with the other services using the private link without going over the internet. It is not a principle, or it is not, how do I say? It's not like you should, this is what you should do. Some people have security requirements, right? That's they limit internet access because internet is generally unsecured, even though you can encrypt in transit. That's using HTTPS. Most organizations would prefer a private connection to a public connection. Besides, since this is private, it means that your connection will be faster than going over the internet. I mean, that's one of the things also. Also, you want to keep certain instances private. Mind you, when you use the internet gateway, you expose them to the public, right? Or anybody can, if you don't set the correct rules, people can access, or others can access your instances. Alternatively, you could use a NAT gateway and then they can be accessed from the internet. Maybe all you want to do is access some AWS services. Then the VPC endpoint is a better way to do it rather than opening up to the NAT gateway, which allows AWS services and all other internet traffic. So it depends on your use case. You'd use VPC endpoints for private subnets. That's what you should remember.
Okay, so again, so it means for, I'm just asking this question based on for exam purposes. So assuming you see a question that, because I've seen some questions like that where they ask, what means can you use to VPC use to connect other AWS services? And now I can see from the notes, I think the third bullet, it says most AWS services use interface endpoint except S3 and DynamoDB. So assuming I see questions like this and I don't see S3 and DynamoDB and they mention other services,
Okay.
how should I?
Let me answer that point. Let me talk about point 3 first before I answer your question. So VPC endpoints are either interface or gateway, right? Almost every service uses internet gateway, the interface endpoints. Even S3 uses or has interface endpoints. However, DynamoDB and S3 or S3 also has what they call a gateway endpoints. I think gateway endpoints are free. Interface endpoints are not. Yes. Yeah. So S3 and DynamoDB have what they call gateway endpoints, and they are all VPC endpoints. Just that different technologies are used. So every other service, there's not every AWS service also that has an interface endpoint, but most have that, and they use the interface endpoints. Now, in the exam, I'm just looking at situations where you'll be asked about VPC endpoints. So typically, I think where they'll ask you about VPC endpoints will be when you have a private subnet. How do you access S3? And then maybe they'll give you multiple options, which will be with the correct answer being NAT gateway or a NAT instance. And so that's one. I'm not sure you have NAT gateway and NAT instance as two different options. It's one or the other. If you have to choose between NAT gateway and NAT instance, definitely you choose a NAT gateway. Okay. So maybe you are supposed to select two. So you have NAT gateway and then the VPC endpoint. If it's DynamoDB, then maybe they'll specify gateway endpoint. If it's S3, a gateway endpoint is correct. Interface endpoint too is correct. Every other service, you assume that it has an interface endpoint. Does that help?
Yes, it does. Very, very, very much. Thank you.
Yes. So if you have a public subnet, you don't need an interface endpoint. Even though you can use an interface endpoint, but you don't need it because you already have a route to access these services. Okay. So then what to take note here is that private link supports endpoint services and then VPC endpoints. VPC endpoints are used to access AWS services privately. Endpoint services are used to access other services from other VPCs. So it could be your own VPC or another person's VPC in another account. That's why you use endpoint. If you want to access somebody else's services, not AWS, use endpoint services. If you want to access AWS services privately, use endpoints, VPC endpoints. Moving on, direct connects. Okay, I think from here, it's not captured in my demo, but I didn't want to spend, let's take a break and come back at 12:10. I've spoken a lot. Sure some of you are feeling dizzy. So let's take a break and cool down. And then we'll come and do the demo. Okay. So 10 minutes, we'll be back at 12:10. We work at software. Where's my time? Yeah, are we all back? But we didn't go anywhere. We have about 50 minutes, right? So let's do this. Let's start with our demo. Okay. Let's start with our demo. Our demo is quite comprehensive today. Looks like every week we keep adding. I have listed about 34 things we have to do in this demo. So I'll entreat each one of us to also do this after here. Maybe when the video is published, you can follow the steps, or on your own. If you remember the steps, you can just do it yourself. So yeah, what we are going to do is we're going to create a 3-tier application, right? If you don't know what a 3-tier application is, say that in the comments or raise up your hand and I'll explain what it is. So we don't waste time. If you don't know what, okay, so we don't know what a 3-tier application is. That's fine, I'll explain. Okay. So when you are building applications, or Christian, do you have a question or you don't know what a 3-tier is, and then try to explain? Is there a question other than the 3-tier?
No, please, I don't know what it is.
Okay, all right. So when you are building an application, right? An application would typically have a database. It would have a presentation layer and then a logic layer. So a presentation layer is what people will see, and then the logic is your what should happen, or how you process what they do on the presentation layer, right? So typically you would want a different server to handle the web, another one to handle the logic or the application layer, then another one to handle the database. You don't put all of them on one machine or virtual machine, right? Some people would use a 2-tier. 2-tier is where the web and then the application are handled by the same compute, and then the database is different. Whatever it is, always the database is on a different machine. So 2-tier, you have web and application combined together. 3-tier, you have them on different, every layer on different compute. So that's what a 3-tier application is. Is that okay? Is the explanation okay?
Yes, this is fine. Thank you.
Okay. So what we're going to do is we'll create a VPC, create subnets for each of the tiers, and then yeah, basically we'll create auto-scaling groups and load balancers like we did last week and all that. And then we'll configure some endpoints also for the private, the instances in the private subnets. So let's start, right? Let's start. So is Daniel here? Daniel asked about the challenges you face when you create your own. Not Clement, there was another Daniel Dodu.
Okay.
It's not there, it's Daniel Dodu here. Dodu, okay, he's here, good. So now, let's see. Let's start from the dashboard. I just want to show something. So see, I have VPC1 here. So this would typically be my default VPC. And I'm in the EU West 2, which is London region. So yeah, that's my VPC ID. And then there's my CIDR. You see here it says default VPCs, yes. So for every region I go to, I should find something like a default VPC there. So I'm changing my region. So we spoke about regions. There they are, all of them, 26 of them. So now I'm in Oregon region, which is US West, is it 2 or 1? It's one of them. You don't have to memorize this one. So it's US West 2. Okay. And there's also my default VPC. So every region has one default VPC. Let me come back to London because that is where we want to perform our demo today. I'll be seeing who has raised their hands whilst I'm doing the demo. So if you have any question whilst I'm doing the demo, unmute yourself and notify me, and I'll let you ask your question. Okay, so let's start by creating our VPC. So I could choose VPC and more. If I choose VPC and more, it allows me to add the other resources we have looked at, like subnets. So you see subnets here, you see route tables, you see network connections, which is so this is giving me VPC endpoint and then internet gateway. I have to select, or I can even add. The web link to join this, you can get it from the meetup. The link is on the meetup. Okay, yeah. So I can update what I want. I can add subnets, choose the number of subnets, whether I want a NAT gateway or not. Okay, but we use this option. We want to do things the hard way. We only learn when we do things the hard way, right? So let's do this the hard way. So let's create VPC. We'll say VPC only. So let's call it Bootcamp VPC, right? Because we're doing a VPC Bootcamp. Now, before we started, I was giving a quick intro about CIDRs and all that. And I mentioned only certain blocks can be used here. So let's use tens or 0 to 0. I think that's different from your VPC CIDRs must be different for every region. So I can't use the same CIDR being used by the default VPC or any other VPC in question. So they must be different for every region, I believe. If you want to do VPC peering, then it is generally it's a best practice to have different CIDRs. Use different CIDRs all the time. Don't use the same CIDRs. It becomes challenging when you want to route traffic from one VPC to the other. You don't know what will happen tomorrow. You may need to route traffic. So this is the CIDR of my default VPC. Let me try to use it here and see what happens. I shouldn't be able to use that CIDR, right? For the sake of this, we will not use the IP version 4. Tenancy is default. So default tenancy means that when you're launching the instance, it would use the tenancy you select when you're launching the instance. When you do dedicated, then we spoke about dedicated hosts the other time, right? Or dedicated instances the other time. Then with that one, it means that you launch your instances into a dedicated host. Okay. So let's create this VPC. Interesting. Okay. So what I said is not true, right? That it must be different. You realize they are the same. However, I can't do VPC pairing with this two. So yeah, it's not a good practice. avoid it. Always use different siders. Okay. So what do I do now? After I've created my VPC, maybe the next thing we can do is create subnet. However, let me delete this VPC so that the subnets don't confuse me. Already, I'm foreseeing some challenges here, because I want to see different subnets. When so let's do Bootcamp VPC again. Let's use our 10.0. That's better. So can do /16. The math is 2 raised to the power 16. That'll tell you how many IPs you can have in there. All right, now let's go ahead and create subnets. Mind you, we created our own VPC, so we need to create subnets. Okay, let me leave the DNS host names first. Let me leave that out and then come back to it later. So let's create a subnet. All right, so let's create a subnet. Mind, we set 3 tier, right? And we want them to be in different availability zones, right? So we'll create 2 subnets for each tier. Each tier, okay. So let's start by creating our web subnet. We want this to be in availability zone A. So select our preference. So the EU West 2 is the region, then the A is the availability zone. There's also a concept called availability zone ID, right? Because AWS, they don't want you to always launch instances in a specific availability zone. They mix them up. They mix them up so that when you see A, it could actually be, assuming the zones are 1, 2, 3, are named 1, 2, 3. When you see A in a VPC, in your VPC, it could actually be zone 3. When you create another VPC and you see A, that same A could be zone 1. So they use that mapping to make sure that you don't create your resources in only one zone, and that it will become, capacity will fill up, right? So that's something they do. All right, so we said there's a 10.10. I'm not teaching subnetting here, so let me just go ahead again. Give my CIDR block for the subnet. But this CIDR block will contain 256 IPs. Not totally true, because some of them are reserved for other purposes, but total number of IPs will be 256. Yeah. Okay. So we'll say this is our web subnet A for availability zone A. We can add another subnet and then call this web subnet 2. And then our preference will be B. So this is what I was talking about. You see the ID is zone A, 2A is zone AZ2, and then 2B is 3, and then 2C is 1. In another VPC, this mapping will be different. Okay, so B, and then we can use the CIDR 10.0.1. You can use overlapping CIDRs or blocks, overlapping blocks. So then we can create, we've done web, so we can do API as our backend, subnet, and then this will be A. And yeah, and then we can start from 10. And then create another one and call this API subnet B. And then say this is 2A. or 2B rather, sorry. And then our block should be use 10 in the other one. So we can use 11 here. 24. If you have a question, unmute yourself and ask. Not about how I'm doing the subnetting though. Then we can call this DB subnet A. And then pick this one. Then we can do 020.0.24. And then add another subnet and do DB subnet B and use EU West 2B. Then our IP will be 10.0.0.21.0. Well, yes, so I've created 6 subnets, all spread across 2 ACs. Yeah, since all of them were created, it means that I got the subnetting right. If you don't understand how to do subnetting, you can watch the videos I sent. So we can see my 6 subnets here. Realize I can also see the other VPC. Not all the VPCs are the same. So I can just filter here and say VPC and choose my custom VPC, which is this one. Now I can see only the subnets in that VPC. Okay, so we've created our subnets. Let me mark them aside. I go on. All right. It takes a while to create databases, right? So let me create my security groups first, then I'll go and create the database. Because the database will take a while to create. So let me create the security groups. So still here, I'll go to security. Let's look at network ACLs. I won't use network ACLs. I've explained the concept extensively, but I won't use it. However, this is our VPC, Bootcamp VPC. So let's see the NAT call associated with it. Realize my inbound here is allowing, rule number 100 is allowing all traffic from the source. That's my inbound allow. This is the asterisk rule number I spoke about, which denies any traffic that is not matched. Okay. Outbound also does the same thing, and then we have the asterisk. I told you that NACOs are stateless, so you have to do inbound and outbound. Now, all our subnets in the VPC are associated with our default NACO. I could actually create another NACO and associate it with a different subnet with it. So it means I'll de-associate it with the default NACO. However, we won't do much with NACOs today. Let's look at security groups. Let's see if we can find our VPC security group here. Okay, so default VPC security group. So this is the VPC ID. Let's see our default security group here. Let's see our inbound. So our inbound says all traffic, all ports range from a certain VPC, a certain security group. We'll look at that. I'm coming. So let's say we want to edit our inbound. We won't edit it, but let's see. Have you seen that our security group ends with 26FD, and then this also ends with 26FD? So it's referencing itself, meaning that any instance with this security group is allowed to access any instance with this security group. So it's restricted to, it's not necessarily restricted to the VPC, because you can create an instance and then not attach the default VPC security group to it. If you don't, then it means that other instances with only the default VPC security group will not allow you. So yeah, you need to understand how the default VPC security group works. But I won't touch this. Let's leave it. We'll create our own security group. So let's create a security group for our database. Mind you, we are going to have load balancers at the web tier, and then we'll have a load balancer at the web tier. We'll have a load balancer at the application tier. So we need two load balancer security groups as well. And then a security group for the web tier, a security group for the application tier, and a security group for our database. So we are going to create 5 security groups. Let's start. Now, let's say web LB security group SG. This is a load balancer. So allow HTTP to the load balancer. That's our description. Our VPC ID is wrong. So we have to select the correct VPC. So a security group is attached to a VPC. It applies to a certain VPC. Now, inbound rule, who can tell me the inbound rule for this? We want to allow HTTP on port 80 to our, why am I even telling you what it is? I think I've already said. So we can choose HTTP here, or say custom port and still enter port 80 here. Source, because we want everybody to have access to this, we can use 0.0.0. Our outbound automatically is allowing everything. So yes, this is okay. I told you guys to tag everything. So we say Bootcamp. Sorry. Let's set this as true. Then we can go. So we created a security group for our load balancer in the web tier. Let's go ahead and create another security group. Now you guys will tell me what that security group should have. So you realize that the security group we just created is the name is web LBS, but the other ones that are defaults are called defaults. Okay, good. So now let's create our web, the security group for our web instances. This is also still in the web tier, but these are the instances. The previous security group was for the load balancer. Allow HTTP to web. Okay, and then these are VPC. What will be our inbound? If you are brave, unmute yourself and tell me the inbound. It should not be overly permissive. Permissive, yeah. Hey, if people don't raise up your hand, I'll call you. If you are brave, no one is brave. Hey, means you understand the session. Yeah, Emmanuel, maybe, right?
Secure share.
Yes, go ahead. Come again. So let's
secure share.
Secure shell. I don't intend to log into this. How will I configure the application there? But I don't intend to log into it. How would end users be able to access my web application? Let's focus on that for now. Yeah, Jessica.
Okay.
Or you, another person wanted to.
Would you add it by HTTP?
Okay, good. So I could do HTTP here. And then what would be my source? That's where it gets interesting.
It is.
All IP addresses.
All IP addresses. That works, but it is overly permissive, right? I'm using a load balancer in front of my web instances. So in natural sense, I'm only expecting traffic from the load balancer. I don't want people to go directly to the web instances. So I can just reference the security group of the load balancer, because the security group of the load balancer will be attached to the load balancer. Do you understand? When I do that, I'm restricting this to the load balancer. Is it okay? Is it clear?
Yeah.
Okay. So now I can reference the security group of the load balancer, which is SG, it starts with SG, and it says web LBS. So this, and that should work. So let's create this. If it doesn't work, we'll come back and update our security group. Okay, now let's go to our app tier. So what happens in our app tier? Our app tier is expecting traffic from the web instances. Mind you, not the web load balancer, from the web instance. So we have to create a group, a security group, or a rule that allows. So this is going to be for our app, or we can say app or API, anyone, load balancer, right? So the instances in our web tier are going to communicate with the load balancer in the app tier or application tier or API tier, whichever name you give it. So allow access from web instances. Maybe I should just give you a picture of the architecture. I think that helps. So let's see. AWS has a workshop, AWS 3 tier. Let me add GitHub to it and see. I think I've opened it before, so let's just look at this. Yeah. Today we've done networking without looking at diagrams. Networking works with diagrams. Good. So this is it. We have an internet gateway. It comes to a load balancer. This is an external load balancer. Then to our web tier. Then to an internal load balancer for our app tier. Then our app tier can connect to the database. The database is multi-AZ. Next Thursday, 10 a.m. GMT, we are going to do storage and databases. Thursday is a holiday in Ghana. So 10 a.m. we'll do our next section. And then Saturday we'll have our final session, which will look at other important topics. So when we come to understand how databases are architected. Yeah, so this is a you call this a multi-AZ database. So this is how it would look like. What we are trying to do, this is how it should look like. I'll add a few things to this just to make sure we understand some of the other concepts we've learned. Okay, so back to our security group. Allow access from web instances to API load balancer. Writing the description is very easy. The rule is where the role work is. So who would tell us the rule for this? I'm waiting. Yeah, Jessica, go ahead. If you want to answer, you can always unmute yourself and answer. But Jessica has the mic now, so Jessica, your hand is up. You want to answer?
I'm so sorry. I didn't mean to raise my hand.
Okay. Do you want to try?
No. I'll try on the next one.
Okay. Why is everybody quiet? Well, we've discussed this over and over and over. Last week, we even did security group. This was security group, and everyone is quiet. I don't want to mention names. I'm looking at your names. I'll mention your names right. Who hasn't spoken today? Okay, there's a hand up. Let me look for the person. Yeah, Daniel. Daniel Clement.
Hello.
Yes, Daniel Clement. Go ahead.
Please, I can't really hear you.
You raised your hand.
Hello.
Can you hear me, Daniel? It seems he's having network challenges. Okay. Oh, nobody wants to hear you. You can't hear me. Okay, that's fine. So our API or our backend or application load balancer, load balancer for the application tier. Let's say it's also listed on port 80. Okay. But then this time I was expecting traffic from the web tier. So our security group could be this. Our security group could be this. And then we move on. Our tags, bootcamp, the value is true. We can save this. Now we want to create another security group. Okay, so we created what, 3? Let's create a security group for our app or API SG. Allow access from API LB. Our app tier listens on port 4000. So we have to change this to 4000. We're trying to do something like this last week. It didn't work. Let's see if it will work today. I have to change my VPC. So you always have to select the correct VPC if you have multiple VPCs. And then now we can use the security group of our web tier. Instead of using the security group of our web tier, we are going to use a load balancer. So we have to use the security group of our load balancer, which is this one. I was going to say that instead of using the security group of the load balancer, we could also use the subnet, right? So maybe in the database one, we'll try the subnet. I didn't tag it, no problem. But always remember to tag your. So let's create our last security group, I believe, for our database, BBSG, and this accepts traffic from our API or backend instances. Allow access from API instances. We have to select the correct VPC. Then inbound, our database will be MySQL. So we have to look for MySQL. The port is 3306. You could alternatively define a custom and then custom TCP, and then you enter the port there. Now, just because we want to try this, let's go and look for the subnet of our app or API. This is 10.0.10.0/24, and then the other one is 11.0. Okay, so this is how you do it: 10.0.10.24, but this is just one. So let's add another one. Yes, I can add one at a time. Okay, good. So I can just come here and add the other one here. Let's just to help us know the different ways. So we are using a subnet here. I mentioned we could just do custom ports, right? So it's still the same. These two are the same. If it doesn't work, we'll always come back and check. So yes, let's remember to tag this. It's a bootcamp. Why they forgot to have a keyboard. True. Okay, so we've created 5 security groups. Now we'll head over to a service called RDS. RDS is a relational database service. We'll look at it extensively on Thursday at this section. But for the sake of the 3 tier application, we still need to deploy an RDS instance. So let's start. It takes a while to create, so let's start creating that one before we move to the other. All right, before I create the instance, I believe I have to define a subnet group. So I can come out here and then do bootcamp BB subnet. And then I'll choose my VPC, which is a bootcamp VPC. Now, remember we had, it's asking me to select availability zones, right? But we're using two availability zones, EU West 2A and EU West 2B. Now to select subnets from this, I defined, so this is where I have a problem with AWS. From here, we can't tell the name on the subnet, but I remember that my DB subnets were the last ones. So that should be this, and then that. So these two subnets. Yeah, so I can create my subnet group here. I need to provide a description. Okay, so let's create this. All right, so we have a new subnet group. You always remember to create that. Now we can go ahead and then create our database. Then we'll use Aurora. Let's look, we'll see the difference between Aurora and the standard MySQL or Postgres offerings. So what should our database be called? We'll call it a Bootcamp DB. We're using this for tests, so let's just use the dev. If we choose production, then we'll need some plenty settings, but I don't think we need that for the sake of this demo. Let's set our password. We could use a random password, but for the sake of this, let's just use the password below. So memory optimized are huge instances, 2 virtual CPU, 16 RAM. That's a lot. I can just use Bestable. Yeah, that's quite small, and I don't have to pay much. Yes, let's do a multi-AZ. We'll explain what multi-AZ is. Basically, to create database instances in 2 different AZs, right? You remember in our subnets group, we selected 2 AZs. So let's choose our Bootcamp VPC. And then, yes, we have our subnets group here. Public access, no. So public access, if you select yes, it means that you can connect your instance over the internet, right? So no means it's only within the VPC. Security group, we don't need a VPC security group. The default VPC, we've created a security group, which is DBSG. So let's use that. When it comes to authentication, we want to use password, not IAM. So I see something. Okay. All right. So let's create our database. Doesn't match at good. So our database will take a while to create. Whilst our database is creating, let's go and create our instances, right? Instance. So where do we go and create instances? Let me do one thing here, okay? Let's enable flow logs on our VPC. Before I create the instance, let me enable flow logs so that we, at least at the tail end, we can see how flow logs work. We don't have any flow logs, so let's create a flow log. I spoke about IAM permissions, right? So we'll call this Bootcamp VPC flow log. We want it to take all connections, not just assets or traffic, not just assets or. We want to put this in CloudWatch logs, destination log group. We can call it VPC Bootcamp VPC flow logs. We need a role. So I think I have a role that allows this. Let's flow. So quickly, let's see. Flow. Yeah, flow logs role. Let's go to IAM quickly and then go and see what this role is doing. just to make sure we still understand our roles or rehashing the concepts of IAM from week 1. So the role was flow. This one. The permission, let's see the permission. So it has CloudWatch full logs, CloudWatch logs full access. So everything to put logs into CloudWatch. And let's look at our trust relationship. So we are trusting this service, VPC flow logs, to assume the role, STS assume. Yeah, so basically that's it, a quick detail. Okay, now this will be the format of the flow log. So we have the version, the account ID, interface ID, source destination, source port, destination ports, protocol. The last one is last but one, action, and then log status. Action is whether it was allowed or rejected, right? So let's create this log, flow log. We could actually specify a custom format, but let's keep the default. So we've created a flow log. Let's go ahead and create our instances. Later we'll go and view the flow logs and see what's there. So right now, I want to create an instance, right? I want to create an instance for our API. Remember last week we did AMIs, right? We baked an AMI with our application. I come to do the same thing here. So let's say app or API. We can start with Amazon Linux. I think that's okay. T2 micro. I'm not going to allow key pair. I'll come back to why I won't allow a key pair to proceed without key pair. I think we can check other concepts. So let's see. We want to create this in API subnet A. No public IP. We'll come back to why we are doing this. And then our subnet is this one. Our security group, sorry. Roles. So instances can assume rules, right? Let me select this rule, 3-tier EC2 rule. And then let's create this instance. I'll tell you what I'm actually doing. So let's go and look for the rule called 3-tier 3. Okay, so let's see the permissions. We have Amazon SSM managed instance call. So there's a service called systems manager. It's used to do a lot of things. One of the things is to remotely connect to your instances. So when you create an instance and then you give it this role, it's one of, or giving it this role is one of the prerequisites for using SSM to manage your instance. And this, I want to use SSM to manage my instance. There's a service called session manager, so that's what we use. So when you give it this role, it will allow you to use session manager to actually connect to your instance without going through SSH and all that. Why do you want to do this? First of all, when you do this, you're accessing your instance directly from the VPC. It doesn't go over the internet. You don't need a security group for that. So that's one of the things security groups don't do. Also, you can actually create a configuration where all the commands you enter into the instance are logged. So for governance and audit purposes, this is like the best way to connect to your instance. However, I think I will not be able to connect to this instance. Who tell me why I would not be able to connect to the instance? Who can tell me? I've mentioned that security groups don't matter here, actually.
Because you didn't add the key pair.
No, SSM session manager doesn't need the key pair. So let's go to connect. Let me show you connect. I have instance connect, I have session manager, I have SSH. So it's only when I'm using the SSH that I need the key pair. When I come to session manager, yes, it won't work. Why? It says the agent must be installed. I use Amazon Linux. Amazon Linux and Ubuntu have SSM already installed on them. I've created the instance profile. That's what I did. It's not going to work because you remember Daniel's question that when you create your own VPC, it is very restrictive. You need to add other things before it works, right? So we don't have any way to get to the internet. SSM is accessible over there, or session manager uses internet. Now my VPC doesn't have any internet gateway or any routes. Let's check our VPC routes. See, route tables. Let's see the route table associated with this is the route table, the main route table associated with our VPC. Okay, so let's open it. There's no routes to the internet, no routes. See, I only have a local target, which is the every IP in the VPC, it's handled locally. There's no route. So I don't have any way of accessing this, the session manager service. However, I could just create an internet gateway and then create a NAT gateway since this is a private subnet, right? But I won't do that. We spoke about endpoints. Let's use endpoints to prove that you can access services privately. So let's create an endpoint. To be able to do this, I need to create, there's an endpoint for every service. So I need to create three different endpoints. If I wanted login in CloudWatch or S3, I'll still need to create an endpoint for that. If I needed EBS snapshots also, I think I need to create an endpoint. So that would have taken me to about 6 endpoints. But I'll only use the essential services. So let's say SSM, we call it SSM. I told you about endpoints for your own services or the marketplace services, right? Okay, but we use for AWS services. So this is an interface endpoint or a gateway endpoint. Okay, so I'm only going to create 3 endpoints for the essential services I need. So I'm going to search for the service name SSM. So that's this one. So that's one of the 3 I'm going to create. So this VPC, I have to select the subnet. So you only need to create you only need VPC endpoints in one subnet in an AZ, in an availability zone. So you can have several subnets in an AZ. You only need to put it in one subnet in the AZ. Other subnets can use it also. So let's just select our, let's say, app. And then over here to select the app. Okay, so selected 2 subnets. This IP version 4. Security group. SSM, right? SSM, let's consider security groups here. SSM or session manager needs your instance to allow outgoing port 443, that's HTTPS. So literally the only which means that any of our security groups should work, right? Because they are all allowing outbound, everything outbound. Or let's use our default security group. If you don't understand, ask questions. So I'm saying that for session manager to work, your instance should allow port 443 outgoing, so outbound 443. And all our security groups, we didn't touch the outbound. So it means that outbound is allowed for every kind of traffic on our security group. So any of the security groups should work. So I want to use the default. Alternatively, I could just take the API one. And then we spoke about resource-based policies in the first session. So this is a resource-based policy. I could create a custom policy on the endpoint, but then I'll just give it full access. This is against privilege, principle of least privilege. So let's go. Private DNS, yes, I was hoping to come to this. So we need to enable, oh, we didn't talk about DNS, but one of the things we need to do is to enable DNS resolution on our VPC. If we had used the default VPC, then that default VPC would have had all these configurations already. But our custom VPC doesn't have this. So let's quickly create it or enable it. DNS host names. So what it does is it allows your instances to have DNS names. So instead of, let's see, let's check my instance here, right? Let's go back. Yeah, this one. Now, this has been assigned, all right, but it can't be resolved unless the VPC enables that. By resolution means mapping it to which, knowing that this DNS name is mapped to a certain private IP, which is this. It doesn't know, even though the private IP is here, we won't be able to tell till we allow this setting. So we'll find it here. Edit DNS host names. So I have to enable this here. You should read about it, DNS host names, and then the other one, DNS resolution. Okay, so this is enabled. Good. Let me make sure DNS host names is enabled again. Let's make sure. Okay, good. So now let's create our VPC endpoint and see. Now that we've done the setting, create endpoints. Yes, it worked. But this is one of 3 endpoints we have to create. So let's quickly go and create the other one. It's a SSM. We have to also create for SSM messages. So this is a lot of, we could have just, where is it? This one. We could have just allowed or use the NAT gateway to access our instance, right? I have to go through this painstaking exercise to do this. So VPC endpoints would actually create a network interface in your subnet to handle all the traffic routing for AWS services. So we are still using this. And then full access. I have already enabled the DNS resolution, so this should work. And then now we're going to create our last endpoint, which is EC2 messages. So let's look for EC2 messages. And then I have to select my subnets. DB API. Okay, good. IP version 4, security group. Okay. So we are done creating 3 endpoints. Okay, let's see their statuses. The last one is pending. Okay. So usually, even after creating the endpoint, it takes a while before you can connect. So you can't wait, but we can move on. We've created our security groups, created a subnet, we've created our RDS. Let's check our RDS. Is it ready? It's available now. Wow. Okay, that's good. We've created our IAM role. We've enabled flow logs. Okay. Created our endpoints. All right. So let's check on our, we can close this window and then check on our endpoints. Sometimes when the reload on the page is not working, you can just do a hard reload. And then see what happens. Okay, it's available now. Let me reload this page and see. You realize that the connect to instance is disabled here. It's disabled. I'm not expecting to work now, so maybe we should still have it here. Oh, okay, yes. So you realize connect is disabled. It has to be able to connect to the EC2 instance before, or have all it needs to connect to the EC2 instance before you allow me to connect. So whilst that's been done, I think I should explain the Bastion host, right? I mentioned already that we don't need SSH keys, right? So Bastion hosts, you realize we have private subnets and cannot be accessed from the internet. So Bastion hosts, the other name is Jambox. They are usually found in, they are instances you place in the public subnets for the sole purpose of connecting to instances in private subnets, because you can't connect to instances in private subnets directly from the internet. So you have to latch onto an instance in the public subnet. Then you use that to access your private subnets. Instances in your private subnets. Yes, Emmanuel, your question.
Hi. So I wanted to find out, so once you attach the role, the SSM role to your instances, it begins to install the SSM agent at once, right?
No. So your SSM agent, your SSM agent comes with the AMI. So I use Amazon Linux too. It has SSM already on it. If you use Ubuntu 2, the latest versions, it would also have SSM enabled. You could also manually install SSM on your instance if it doesn't come with it. But that would mean that you have to maybe use SSH to log into it first of all, and then do the installation, or maybe you install it as part of your user data when you are creating the instance. Yeah.
So what could be the reason for the SSM, the session manager not able to find your instances? What could be some of the factors?
Okay.
Yeah.
I think they've even listed it here. The first one is you don't have the SSM agent. You don't have the SSM agent installed. So with this, you can resolve it by calling manually. And then the second one is you don't have the instance profile, which has the SSM permissions. And then also, if you've not completed your session manager setup. So this usually takes a while. It's possible something is blocking it and I'm not seeing and giving the excuse that it takes a while. Even if you do everything right, it takes a while. So I want to believe I've done everything right and it's taking a while. But yeah, so these are the prerequisites: supporting operating system, the agents. You need the VPC endpoints, which I have done. I think those are the main requirements. Alternatively, what I can do is go to SSM. So that's Systems Manager. Okay. And then I'm tempted to go and look at my IAM role, security group. Okay, so let's go and look at our security group. The security group we attach to the endpoints. This security group. We said, oh, who can tell me what is wrong? You remember I said that the instance needs to allow outgoing for port 443, right? However, for your endpoints, you need to allow inbound for 443. Do you get it? And I'm using this one. Good. So that's why it will not work. So let's create a script for SSL. Allow. Oh. Then our. So let's create. We said HTTPS, right? From, let's say, from our VPC. These are targets in the subnet. So yeah, we can use our VPC. That's okay. Then let's create this. Now we have to go back and attach it to each and every one of our endpoints. So let's change our security group. We call this SSM, modify. So we've done for SSM, 1 of 3. SSM messages. SSM. And then the last one is visitor messages. Security groups, manage. And then select SSM. Okay, we should be in business, right? So security groups, they are your friend. Okay, so I opened SSM. When it comes to SSM, you see all the things SSM Systems Manager does, a lot. A session manager is, yeah, I can find session manager. It's just one of them. Can you use Systems Manager to actually patch your instances? Create a patch schedule for them. So usually all your instances that can be managed by SSM, you'll find them here. Alternatively, I could just go and open the security group to allow everything. But it usually takes a while. Let me also make sure that my instance has the IAM rule. I remember attaching the IAM to it. Yes, it's here. I have the IAM rule. Okay. So let me just confirm. Okay, status message. Okay, that's okay. So my database is ready. What other things can I do? Wow. If I create the NAT gateway and the internet gateway, will mean that I am using, okay, anyway, I won't create a route to them. So that could work. Okay, so let's create our internet gateway. We are just creating the internet gateway. We are not necessarily creating a route. Okay, so let's create an internet gateway. So it's quite easy to create an internet gateway. Just select internet gateway, Bootcamp, IGW, and then that's it. You don't need to do anything else. After creating the internet gateway, let me open another tab for the routes. We still have one route table, which is the main route table, and then only the local routes. So now let me associate the internet gateway with our VPC. So let's associate this with our VPC. So attach it to the VPC. Then our VPC is the Bootcamp. Then attach. After attaching this, you realize our route table is here. And the routes is still the same. I now have to come and add. So let's look at subnet associations, right? We don't have any explicit, but we can come and attach our public subnets because we need, they are the ones that will use the internet gateway. So web is our public. So that's the only subnet that will associate with our main route table. So we've done an explicit association. The other thing we need to do is also create a route to say that from these subnets, if we have any destination, which is 0.0.0, it should go to our internet gateway. And then that will allow our web subnets to now be a public subnet. So this does not allow our private subnets to be accessed or access the internet. Session. Okay, so it's still not working. The last thing I can do is just go and change the security group to be overly permissive. Now you can use VPC flows to check what exactly is happening, right? So let's change this. Oh yes, I could actually use VPCs. Let's take this. Let's use this as a way to view our VPC. The only problem is that I think there's a way around that. I'll watch logs. So log groups. Each interface should have what we call a log stream, and we are using 3. Good. So this was what I was talking about. There's no way to tell what this is, right? But the way around this is to come to our endpoints. And then from here, we look for the network interfaces. So each one is creating two network interfaces. So this is 34034. Let me start with SSM first. The SSM. 34 or 4083. 4083. 4083. Let me look for that. 4083. These are the logs received so far. So no data, okay. So it's not even reaching it, okay. That's fine. So our candidate is definitely a security group. Let's go back to security group. And then we created a security group for SSM, so we can update it to just allow everything for now. So we understand our traffic, what is happening. So all traffic, maybe we can even allow 000 for now. Okay, so now it's overly permissive, just to make sure it works. After that, we can decide on what to do. Okay, so let's go back to EC2 and for instance. So it works now, right? Because I can see this connect enabled. So just to rehash, SSM doesn't need SSH keys. It can connect to your instance within the Amazon network. So if you have an internet gateway or your instance is in a public subnet, then that should work for you. If it's in a private subnet, you can use a NAT gateway or what do you call it? The VPC endpoint like we are doing here. So now let me check. Oh, it takes a while to gather the data, so it wouldn't even appear right now. So we can just go ahead and connect and start what we want to do. So there's actually a workshop. I'll share the link with you, and then you can use it. There are a few things we need to reference from there, but yeah. So we are connecting to our instance. This is our backend. Mind you, we've not configured our database. So when you connect to it, we'll see if we can connect to our database from here. Let's remember that our database security group is allowing access from the API instances. Good. Okay, so we have the shell here. We can switch to bash. Yes, and then I can switch my user to EC2 user as the default user on the Amazon Linux. Good. Can also change my directory to the home directory. And then I want to update this, but I shouldn't be able to update it, right? I want to update my packages. I shouldn't be able to update it. Who can tell me why I can't update this?
Is it a security group?
No. Our security group is only allowing, mind you, updates is outbound. So we've allowed all outbound traffic. So that shouldn't be the problem. I'm using interface endpoints to connect to this. So that solves the problem of managing the instance. However, the instance is in a private subnet. That tells you that I mentioned that the internet gateway I've configured would only work for instances I put in the public subnets, because I only associated those with the main route table, which has the route to the internet gateway. So this instance does not know how to get to the internet. To prove that, we can we can write ping 8.8.8.8. That's Google's. Yeah, there's no response. There's no response. So yes, we don't have any access to the internet. So that's where we now have to create a NAT gateway to solve the problem of allowing internet access. Is that okay?
Yes.
To prove that we don't have internet, you also realize we don't have a public IP. It's blank, it's only private. Okay, so now quickly, let's create our NAT gateway. Where is our NAT gateway? NAT gateway. So Bootcamp NAT gateway, NGW. We have to select our subnets. Our subnet should be just the API. We don't need our database to access this, right? So sorry. Our subnet here is the subnet we want to put the NAT gateway in. Where should the NAT gateway be deployed? Which subnet? It has to be a subnet with internet. It has to be a public subnet. So we choose Web A. And then our subnet is public because we want access to internet. Private subnets will allow you to connect to, I think, other VPCs and on-prem. Yeah. And then I mentioned we need to use Elastic IP. So let's allocate an Elastic IP. We don't have an Elastic IP. Elastic IPs are free, but if you don't use them, you pay for them. So when you stop using it, when we are done and we terminate the NAT gateway, we have to go and remove the Elastic IP as well. So that's what we need to create our NAT gateway. Yeah, Daniel.
I have a question on assigning the Elastic IP to the what do you call it?
The NAT gateway.
I thought it's a managed service, so you are not responsible for the overhead management of the gateway. So the Elastic IP, if it's a managed service, it defeats the purpose. I'm not getting it.
Okay. The reason being that, remember I said that when the instances the private subnets want to access the internet, they will go and use the public IP of the NAT gateway, right? And that's the Elastic IP here. Now, maybe you want to allow access from a certain public IP, or you are connecting to a third-party service that whitelist IPs that can access it. So by allowing you to use an Elastic IP, you can share that IP with the third party to whitelist for you. And this IP is in your account. It won't change. When you create a new NAT gateway, when you delete this NAT gateway, you create a new one, you can use the old Elastic IP, which has already been whitelisted by a third party to access the service. Is that a good explanation? Do you understand? So it's just for the purposes of you keeping track of the IP or having an IP that does not change.
Sure.
Okay. Okay. It's available now. Okay. So after it's available, we have to create a route table. I told you that this our demo has everything we've learned. So private RT, our VPC is the Bootcamp VPC. That's tagged it for me. That's okay. So that's very simple, creating a route table. Now we have to come and associate subnets. The subnets we want to associate is our API, since it's a private subnet. So there are two of them. We'll quickly associate it and save. Then the last thing we do here is to create a route. So for all the subnets that have been associated, if we want to go to 0.0.0.0, our target should be the NAT gateway. And then now we can select our NAT gateway, and then we save. So now that we have added the route table, let's see if our thing will change. Okay, good. So now let's go and we get a response now, right? But there's no way to connect to this IP directly because it doesn't have a public IP. So now let's go ahead and update our packages. You realize it's also working. So yeah, like we learned, that's what NAT gateways do. They give internet access to to instances in private subnets. So yeah, we can update this. Now back to our workshop. This is our app tier. So we want to quickly configure the database. We need to install MySQL. Okay, we are all tired, but let's finish this, okay? So I'm installing MySQL now. Okay. I also install Git because I use Git to download our code. So where do I even find our code? Get up, right here. Okay, so to do this, I need to come here and get the URL. And then now I can do with okay, good. So I can do git clone. Good. So now I have a new, this is it. So let me copy, paste. Should have seeded first. Let's do this. I'm just changing direction, sorry. CD application code. And then now we have our app tier. So I'll seed into our app tier. Let's see what we have in our app tier. So it's a Node.js application because you can see a packet.json. This is our database configuration. So let me quickly, before I even touch the database configuration, I think I installed MySQL, right? So let me connect to our database. If it works, then our security group is working well. Okay, so we created a multi-AZ. We have a writer instance and a reader instance. The reader instance is only used for reading the database. Writer, you can write and then read. So let's get the endpoint. That's what we'll connect to. Hey, why? People don't have them. Okay, good. So which one is it? Writer. Okay, good. So let me copy this. And then MySQL would require, let's say, MySQL host this, and then user should be admin, right? And then a password. Password was, I'm connected, good. Show databases, good. So we can say create database. What's the name they give to a database? Web app DB. Web app DB. And then we'll do our databases again. Realize database has been created. So we can use web app DB. So our database has changed to web app DB. Okay, So let me go and enter a few of those database. So let's create our table. Let me just copy this, right? Create our table. The name of the table is transactions, okay. And then show tables to make sure the table was, even though it says, let's show tables. Okay, yeah, we have it. The next thing is to insert a transaction. So let's insert this transaction or an entry into the database. Okay, that's also been done. And then now we can select all the records we have in there so far. So yes, we entered an amount of 400, and then the description is groceries. Okay, that's good. That's fine. Now let's configure our application. The first thing we'll do is to exit from our database. We've been able to successfully connect to it. And so let's configure the database. I think we can get that. We can do that configuration from dbconfig.s, which is one of the files we have here. Good. So I have to go and get the host name and put it here. Where do we get the host name again? From here. And then I paste it here. Our user is admin. Our password, which I didn't tell anybody, now I have to let everybody see it. Where we can, and then we said web app DB, right? So that's our database configuration. Now I believe we need to install Node.js. So we use npm to install Node. Okay. Let's just make sure the changes apply by running the source /c of the environment variables. Okay. So let's install Node using nvm. Should have used I should have used version 16 or the same. Okay. So Node is installed. Let's check. Okay. Let's see. Can't seem to get my Node. Let me see if it works. Okay. Let's install PM2. Okay, so our installation didn't work. Let me go back and then install Node version 16. Rather, nvm install 16. Okay. Now let me run Node version again. Okay, good. So that works. Now let's use the version 16. Good. Then we can run our, we can install PM2. So PM2 would basically run our server as a daemon. This will help us to be able to bake it into an AMI and then automatically to start when the server starts, right? Okay, so now let's install our packages, Node.js package. So npm install. Okay, successfully installed it. The next thing to do is to start the PM2. So let's see. Okay, so PM2 start. Index.js. Okay, good. So we can kill localhost. That's just making sure this works. I think it's health. This is the health check. Okay. When I do transaction, that should have, that should return our database. You can see here what we have in the database, 400 and groceries. So yes, our backend is working perfectly. Okay, that works. That's good. Now let's demonize this. To demonize this, we need to save and then start up. PM2 save and then PM2 start up system D. Okay, now I have to copy this and paste it. I have to copy and paste it so that every time copy, paste. Good. So what am I going to do now? Let me create an AMI from this. Security image, create image, API, AMI. Okay. And then let's create that. Whilst that is creating, I think we can go ahead and create our front end, right? Or whilst we are creating our AMI, we can go ahead and create configure our front end and then create an AMI for it. That would actually not work because I need to do a configuration for the load balancer. So let me create the load balancers. We'll create the load balancers and come back to them. I need the load balancer in the backend configuration, in the front end configuration. So let me create a load balancer. We'll create one for web and one for the app. So web, our web is internet facing, so we'll leave it as such, IP version 4. So every week we have this, right? I think it's become, are we all back? Hello?
Yes.
Are we all back?
Yeah,
Okay.
yeah, Emmanuel.
So every week we have to go back and then go off and come back, right? So that has happened to us this week also. So I'm selecting my web subnets. Okay, web, good. All right. We selected our load balancer. We are listening on port 80. I don't have a target group yet, right? Let me save this and see if it will work. No. So let's create a target. Whilst that's happening, we can check if my AMI is ready. So target group. Our targeting instances, our port is 80, our target group is web target group. VPC is Bootcamp. Our health check can be on the / port 80. We have port 80 here. Health check, we don't need to do anything because we're still using traffic port. So next, I don't have any targets. My API is not running on port 80, so I can't select that. Let's just create a target group. Let's create another target for our backend. So API target group. Our backend listens on port 4000. So let's select this. Our health is on /health. So there's a difference. And traffic, and then yes, next. Okay, I could actually select that, but I don't need to. So we've created 2 target groups. In our load balancer, we can reload and then select the web. Okay. Then create the load balancer. Let's go and create another load balancer for our backend. So API. There's no internet facing, it's internal. The first one was internet facing. Bootcamp. Then this will be in the, so let's select API LBSG. This will be in the API subnet. So we'll send traffic to this guy, API TG. And then we don't need to use any advanced services. So yes, we need to use API. And yes, one also needs to use API. It means I'm tired. Finish right now. Okay, so let's get to our load balancer. Now let's check our AMIs. Are you ready? Yes, you're available. Just to make sure all the things we did were right, let's intentionally launch an AMI from this guy, right? So let's launch an instance from that AMI, just to make sure it worked up to. And then we use our AMI and no keeper. Our network is this guy. We'll launch you into our private, this one. And then we'll launch you, we don't give you a public IP. We use an existing security group, which is API HG. And then we give you this role. Yes, we are set up for success. No keepers. So today, keepers are not our friends. We found a cooler way to connect to our instances. Okay, so let's wait for this guy. Whilst we are waiting for him, we can also go ahead and create another instance for our web, where we are going to configure our web tier. Web. we have to do a lot of things concurrently, right? Because we don't have time. Proceed without keeper. Then it's almost 10 minutes to 2. Okay. So this should be in the web tier. So let's do this. We can assign a public IP, it doesn't matter, because this is the public subnet. We want to select an existing security group. This is WebSG. I can assign the same role to it so that I can manage it using Session Manager. Okay, so this was our app 2, right? Let's try and connect to this guy and see if it works. Okay, let's connect. Because I can't access it over the internet, the only thing I'm going to do is I'm going to tell localhost 4000 health and see if it works. If it works, that means that our application is running when it was created from the instance. That's shf kel localhost 4000 health. This is the health check, so it means it's running. Let's check our transaction endpoints. So this for my AMI. Okay, yes, we still have our 4000, so it works. We can use this on another. So I'm going to terminate my 2 instances because I don't need them. I can afford to terminate them because I have an AMI already. Now my web is working, so it's up now. So let me use Session Manager to connect to it. We need our load balancers. Now let's go and configure our web tier. Our web tier so I switch to Bash. I switch my user. I switch to my default directory, and then now I do a YAM update after I come and install Nginx, among other things. Okay, so I have to replace my, okay, so let me install Git first because Git will allow me to download the application code again. So let me go and get the URL, then Git. Yeah, you have to do this on your own though. So maybe when we release the video, you can use it as a guide and then do it on your own, just to make sure that you grasp all the concepts. So sudo yam install -y git. And then I can go and clone. After cloning, I can copy you, copy and cd paste, and then application code. All right, so now I have the Nginx configuration here. I can copy that, and then I have to update the, so it's using a proxy here. I have to replace this with my API load balancer. So I have to go and copy the URL. So this is how we do real life application stuff, right? So API, this is the load balancer. I have to paste this here. Okay, I believe that is it. So I can save this. Then now I need another window for Session Manager. So I can just copy and paste the URL. And then, but what I'll do here is, let me pwd here. Okay, good. So I'm going to copy the, I think I can find an Nginx directory from there. Okay. I have not installed Nginx. Makes sense. So now I have to go and install Nginx. I have to go and install Nginx. So I'll install Nginx with this. Can be found in the Amazon Linux extras. So let's do this. All right. Now my other session is open, so I can enter bash sudo user. Okay, so I can rather use this since I don't have. I can use this guy to. So this is the default configuration for Nginx. I'm going to delete it. So I'll replace it with my own. All right. To replace it with my own, I can come and copy this long thing here and do copy. And then we'll say cp / this / Nginx conf to etc Nginx. So with permissions. That's why I like our security groups. Okay, good. Now let me check my directory if I have the file here now. Okay, good. I have it here now. Okay. Now to the interesting part. Let's configure our web tier. I don't have the guy running, right? I don't have Node.js. So let me install Node.js again using nvm. And then the next command is the source partial C. Okay. So I've already cloned. Now I have to be in the web tier and then do npm install. So yes, I'm in the web tier, so I can install my packages from here. I think after I can run the npm run build, which is the React command for oh, I think there's one thing I didn't look at, right? So let's look at our Nginx configuration. The location of our files. See, it says here, my home directory, web tier. All right, now my web tier is in some SAP folders. So I have to make sure that is taken care of. Okay. So our npm is running. I think I can use, for npm is running, I need to let it finish first. I'm installing our packages. I need to let it finish first before I can move it. It's 2 o'clock. Our demo has taken how long? Almost 2 hours. Interesting. So we are practicing everything we've learned. I hope I'm still recording though. I'm not recording. Saniba. Okay, good. So now let me see PWD. All right. So I have to move. There are 2 things. Either I move this or so I can move my web tier. So let me just come here and then do CPR. I'm copying web tier. So I can copy it to home. Once it's taking long, it means it has worked, right? Or it's copying. Okay, so let me ls the home and see. Yes, it is there now. So let's go to our home and then cd into web tier. Does it work? Yes, it's there. Good. So I have my node models here. What prevents me from running the npm run build? Yeah. So we are building our code. Those of you who have some experience with React apps, after you create your application, use this command to generate the HTML and other files, right? So we've done a lot today. So where are you? We are done. Okay. So we'll find them in the build file, in the build folder. Okay. One other thing I have to do now is to give Nginx access to that directory. So what do? I change the permissions. So let me just copy this, okay? There's no a Linux class. It's yeah, so this will give Nginx permissions to that folder, so I can save files from there. Then let me restart my Nginx so that it would apply the configurations, the new configurations. And then also, let's ensure that when we restart our instance or it's created from scratch, Nginx will run. Okay, so now that we have done all this, now let's kill localhost and see. 4,000, hey, 4,000. Good, I have a response. Let me analyze this and see. We have a React app. Okay, so basically it's working. Since it's working, I don't want to, mind you, we can't communicate with this over the internet because of our script, so we can't view it. That's fine. All the same, let me go ahead and create an AMI from my web instance so that we can use that to create an auto scaling group. Okay, so let's create an AMI. Image. Web AMI. I think I've done everything I need to do, right? Now let's go and create our launch template for the backend. From the launch templates, we create an auto scaling group. Then now we can register our targets. So you are called API LT. And then you are based on our, not web AMI, API AMI. And then your instance type will not include a key pair. Instance type will be a T2 micro. Subnet, I can leave out the subnet and then select it from the auto scaling. So our security group has to be the API security group. Today, dear, today, we can go ahead and then add our IAM. I guess that's all we need to do, right? I guess so. There's something else we can come back. So we've created the launch template. Since we are here, why not create a launch template for our web? WebLT. Similar, my AMIs, yes, we use the web AMI. Instance type should still be a T2 micro. We don't need to add a, we can skip this, we can select our web. And then advanced, we select a row, a profile, sorry, instance profile. And then now we can create the launch template. Now all we have to do is create our auto-scaling groups. So what are my auto-scaling groups? There they are. You have to create an auto-scaling group. We start with the application, AHT. We have a launch template, which is this. The next. And then VPC, our subnets, we can select our API and where's that API? API, good, subnets. And then we move on. We would use okay, I can just say no load balancer for now. Don't worry. So let's set our capacities to 2. Today we'll not use a scaling policy. We looked at that last week already. So no notifications yet. And next. And then let's create this. Now let's go and create another scaling group for our web. It's here. Web, ASG. We know our launch template. Let's finish hard. We're almost done. Let's finish hard. Then we have our web. We have our web. So 2 subnets. Next. No. Also 2. Next. I could actually say skip to review, right? All right. Now it's time to go back to our target groups. Let me delete, let me close some of the pages. We can connect to our instance, so we don't need to see it here, right? Okay, so now our target groups. Let's go back to our target groups and now register our targets. Last week, this is not how we registered our targets, but let's see. Oh, I didn't name my targets. Okay. I should have named them in the launch template. That's not a problem. We can always solve that problem. I just say we can always solve that. So I have I can use the API. Okay, good. So you are API. It's good to name your instances when creating the. I didn't do that, but that's okay. Okay, so now that I've done this, I should be able to refresh this page and then get a name. Okay, so now I have API, and then include as pending. Then I can register them. So this is how we created our target groups from last week. Let's go back, go and select our web. Let's register some targets. So we have a web. No, if I use this, I'm going to get it wrong. Mind you, we had an instance before. So I believe, okay, so it's this. I've not named my web instances. So it's this. The one I have here is from the what I used to create my AMI. I've not deleted it yet. Okay, so let's go at target groups and then check our first target, which is this one. They are healthy, that's good. And then our web. They're also healthy. So what do I do now? I have to go to what? Load balancers. And then select my web. This is the URL of my web load balancer. And then enter it here. And then what happens? Yes, it works. Okay, so that's the home page. Let's check the database, PBW. Realize I entered groceries, right? And we have groceries here. So I can just go and add, what should we add? Few. And then it's here in our database. It's reflected here in our database. So that's the demo. With all the security groups and all that, you realize, yeah, it works. Any questions? Time is fast spent. Any questions, or we are all tired? We should close. I, for one, I'm tired. Okay, Daniel, go ahead and ask a question.
I have two questions, but I didn't want to interrupt. So
okay,
let me start with the recent one. So with the AMI, your previous configuration on the instance, such as the packages you install, like the Git and all that, once you create an AMI image, you have it in there. And that's what I wanted to ask. Okay.
Yes, please.
And the other thing is that when you were you created a NAT gateway, and you specify that for any other traffic in the route table, it should go through 0.0.0. But I didn't see that for the route table in the public subnet assigned to the public.
All right. So let me go. Are there any other questions? If you have any other person has a question, you can go ahead and ask. Route tables, good. So I have two route tables for this is my VPC. The first is the main route table, and you can see two subnets have been associated here. So let's open that. Okay, let me just click on it. When you check the subnet associations, this is my web, which is what I'm using for the public, right? And that's my main routes table. Now let's look at the routes in there. I have a 0.0.0 to the internet gateway. This gives it internet access as well as allows it to be accessed from the internet. The only reason I cannot access my web tier from the internet, I mean the web instances from the internet, is because of my security group. Because I didn't allow that in the security group. But I have a definition for those two subnets that when they are going to 0.0.0, you should go to the internet. And then let's go and look at our other subnets, for, our other route table for our private, our app or API tier. That one you realize is associated with the API. So there was no association with for the DB subnets, right? We don't need that. So you see my subnets associated here, API subnet A and API subnet B. That's where my backend is. And for 0.0.0, that goes to the NAT gateway. Does that answer your question?
I think so. I was thinking that there has to be a route for the NAT also in the public.
The NAT is in the public subnet.
Okay.
I created the NAT gateway in the public subnet. So the main route table takes care of that.
Okay.
Yeah. Any other questions? Or we close? I'm in a hurry to close. So I'm going to count to 5. If I don't see any hand up, then we close. 1, 2, 3. Okay, Joey. Or you?
I think you've overloaded us with.
Yes. Today was an overload. You can see myself. I'm struggling to keep up. Tired. Talking for over 4 hours. Wow. Okay.
Thank you.
So I guess we'll close here, and then we'll share the video and then the slides, and see you on Thursday. Thank you, everyone. Have a good weekend. Bye-bye. And I have to stop recording.